If you're using polyrope to pull fiber optic cable, you're getting burned, and you're not the only one. In the long run, everyone gets burned: the contractor, the cable manufacturer, and the end user. That's because with rope, where there's friction, there's burn-through. The simple repetitive motion of rope rubbing against plastic duct can melt a groove clean through inner duct after only minutes into a pull. And that groove is precisely where your fiber optic cable is likely to get stuck or damaged during the pull. That can mean serious downtime and labor costs that no one budgeted for. If the cable gets stuck, the crew will have to locate the site of the failure and dig it up for repair or replacement. Or worse, they may just apply more tension and yank the cable free. If that happens, the real damage may not be discovered until the end user complains, most likely to the cable manufacturer. That's because forcing the cable through the damaged conduit can create microfractures in the glass fibers, causing the cable to fail prematurely. Either way, everybody gets burned. Whether you dig up the damaged cable now or later, it still means downtime and overtime, not to mention the costs associated with replacement and repair. But there is an alternative. As a leader in the wire and cable industry for nearly half a century, NEPTCO is actively engaged in educating outside plant engineers and fiber optic cable installers about the dangers of using rope to install fiber optic cable. Recently, we took our study out of the lab and into the field. In August of 1999, NEPTCO enlisted the support of Conducts International, a leading manufacturer of tools and equipment used in the installation of copper and fiber optic cable in underground conduits. With the assistance of Conducts engineers, NEPTCO conducted an above-ground test to demonstrate the effects of pulling cable in buried conduit, first using Muletape and then using polyrope. Conducted at the Conducts training facility in Mankato, Minnesota, the test was designed to replicate typical below-ground pulling conditions. Approximately 1,000 feet of high-density polyethylene pipe was laid on the ground in a configuration that included several 90-degree bends. In the first test, a Conducts blower and an interduct projectile were used to blow NEPTCO's Muletape through the 1,000-plus feet of interduct. The 1,800-pound polyester Muletape was then attached to the Conducts fiber optic cable puller and pulled at a rate of 125 feet per minute. Seeing is believing, but you can actually hear how smoothly and effortlessly the pre-lubricated Muletape glides through the interduct even around the 90-degree bends. And the cable moves just as smoothly, with no danger of snapback, thanks to Muletape's low elongation properties. Next, the 3/8-inch polyrope was tested, using the same equipment and identical parameters. You can hear the difference immediately. As the rope surges, it actually saws through the plastic conduit. That's because the rope elongates as the cable resistance increases, and the resulting friction is concentrated at various contact points throughout the pull, due to the rope's round construction. Nowhere is this more apparent than at the sharp bends in the duct, where the surging rope burns through the conduit in seconds. Of course, the real danger of using rope becomes evident when the fiber optic cable reaches the jagged 90-degree bend. As the cable is forced through the rough edges of the frayed plastic, its jacket is scored and the fragile optical fibers are subjected to excessive stress. Well, note how quickly the cable jacket shreds. A Conducts electronic control system was used to measure tensions and precisely monitor the force exerted on the cable during both the Muletape and the polyrope pulls. Each foot of the pulls was recorded and documented by the Conducts chart recorder. Anything over 30 at 600 pounds is over the fiber optic manufacturer's guidelines for tension. The results of our experiment were conclusive. Use polyrope to pull fiber optic cable and you'll get burned. Not only do you risk stripping the cable jacket, you risk cable failure due to microbending and crushed fibers. Records from the tension meter clearly indicate that the cable pulled with the rope was subjected to more than 600 pounds of tension several times during the pull. That's well over the cable manufacturer's installation specifications. The cable pulled with Muletape showed virtually no damage to the jacket or cable core. The cable pulled with polyrope, however, showed signs of severe wear on the jacket and major changes to the shape and size of the core. Muletape not only greatly reduces or eliminates damage to conduit and interduct, it also has many other cost-saving features. Because of its high strength and low weight, it can be blown directly into the conduit, eliminating the need for string, rope, winch line combinations. It can also be pre-threaded into new interduct. Muletape has drastically lower stretch characteristics than standard polyrope, so it's less prone to crush capstans or cause injury due to snapback should a break occur. Muletape is available printed with footage measurements, so you'll know exact conduit measurements, where the cable is at any point during the pull, and how much tape is left on a partial roll. Muletape can be left in a duct for extended periods of time and still retain all of its pulling strength. And with detectable Muletape, you can locate the duct quickly and easily. Nepco's detectable Muletape works at a wide range of frequencies and is compatible with all standard detection equipment. So, before you reach the end of your rope, try Muletape or detectable Muletape on your next pull. Protect your cable, your duct, your crew, and your reputation. Don't get burned, get Muletape.